Ah. Cool. All right, do we have all the chairs filled in yet? Not quite yet. Maybe we could wait one more minute. Well, why don't we just start, and then we're going to cover some intro stuff first, so people who are late won't miss too much. Hi, I'm Jim. It's a cozy class today. I feel like it's pretty small, so feel free to ask questions and chat with your neighbors when we do some of the exercises to work for help. If you guys would like, you can load these slides at this link. It's not required. The slides work in Chrome, the Chrome browser. I haven't tested them elsewhere, so if you get problems displaying them, it's not a big deal. For example, this slide has some of the commands we'll be running. This is the excuse me, the command I sent out already, so many of you guys have probably run this. But if copy and paste, if you need to copy and paste from commands, this can be a little bit easier. So, as I sent out, let's jump in. If you can clone the skeleton code, if you haven't already, and set up virtual env, the only requirements for this are going to be mrjob, and as a optimization, there's a simple JSON library that you can install, although I've seen some folks have trouble installing it. It's not that big of a deal if it doesn't install. So just so I can get to know, how many people have done this already? Awesome. You guys are awesome. Okay. Does anyone want to see this slide a little bit longer? I can also go back to the slides, a slide link if you guys want to load those slides. Just call it out, let me know what you want me to do. So I'll talk about myself for a little bit. I work at Yelp. I'm an engineering manager now, though I've helped a lot writing mrjobs for production. Yelp probably has dozens, if not close to 100, different mrjobs that we run daily. We run them on EMR. Today we're mostly going to be running them locally on your own machines. Although at the end we'll do a quick demonstration of how to run these in EMR. mrjob can also connect to an existing Hadoop cluster to run if you guys have that back at your jobs. Let's see. So can I move on from this then? Perfect. So the agenda for today, we're going to be talking about what is MapReduce. For those of you who don't know, we'll talk about writing an example job in MapReduce, and then we'll go into these exercises. The exercises are going to be done. We're going to take some time out, and you guys will have a chance to fill in some code. There's mostly skeleton code already, so you'll just be filling in some of the key parts. It's not like a test. You can talk to your neighbors to figure stuff out. Raise your hand, ask me. I'll walk around and help for a little bit. But I feel like doing these a little bit on your own really kind of hopefully solidifies the knowledge that I'll be talking about beforehand. So after that, we'll be talking about how to join data together, or do a self-join in our case. Exercise 2, we'll go over that. At that point, I think we'll be close to the 10:15 lunch break. So if I start running into that and don't notice, please raise your hand and say, I'm hungry. Let's go eat. And then after that, we'll be talking about multi-step jobs, so more than one MapReduce step. and then going into what protocols are for mrjob. And then we'll be using some Yelp data, a sample of the Yelp data set to look at data from reviews and user-user similarity, and then kind of putting it all together in exercise 4. Finally, I'll talk about AWS and how mrjob fits in there. And if we have time, do just a quick demo of what that looks like. So I want to make sure that I cover the stuff you guys are interested in. So if anyone could raise their hand and tell me, like, why did you come here? What are you interested in? What are you really hoping to get out of this? So I can make sure to, like, maybe glaze over the material that people are less interested in and dive into the material that people are. Yeah. Currently analytics. Okay, great. Yeah, so we'll be going, we'll be looking at some basic analytics, but hopefully it'll be clear how to extend that. Anyone else? Who knows MapReduce already? Great. Okay. I won't belabor that then. And anyone else like really interested? Who thinks they'll be deploying this on AWS? A couple people. Okay. Cool. All right. And if you guys could look to your left and right and introduce yourself to your neighbor. So just tell them your name and maybe how many years you've been using Python and maybe your favorite Python function. Awesome. Yeah. PyCon 2014, and then the password is PyCon 2014 lowercase. Yeah. All right. Thanks, guys. Man, you guys are a very sociable group. I like it. I was afraid everyone would be like, "Hello, I am Jim," and then face back to me. This is awesome. Cool. Okay. So as I said in the email, you can run a quick test. Let me make this the right size. You can run a quick test to make sure everything's working here. I tried to word wrap this a little bit, but basically you're echoing hello into this word frequency example. And we have a long path here because this is where mrjob is installed in your virtual environment. So if you could run that and make sure everything's working, we can skip any problems that we might have during the tutorial. Yes, in the shell, exactly. So this will require you having activated that virtual environment as we did on the second slide. Are the slides just in your mrjob? Yes, they are actually, yeah. If you clone that, you get the slide. And in order to get it in this like presentation mode, there's actually a little box down here that you can click on toggle slideshow mode. Don't skip ahead in the slides. Well, if you want to do the exercises yourself, don't skip ahead in the slides too much. There's a couple seats up here too. All right. Anyone having trouble running this? Everyone's. So this should output some debugging information and then just a word count, which will be hello and 1. All right. All right, so a little bit of background about MapReduce and mrjob. So Yelp has a problem. Like I said in the intro, we have, at this point, well over 250 gigabytes of logs per day from our web service, from mobile, from all of the batches we run. And let's say each gigabyte takes 10 minutes to process on a single machine, right? So how long would that take? If we were just running these on a single machine, how long would that take, you think? Math whizzes out there. So it'd take well over 40 hours. And obviously that's not going to work, right? We're going to run behind immediately as soon as we start processing the first day. So, so how can we fix this, right? So if the problem is running on a single machine, how can we fix this problem? Anyone? Yes, run on multiple machine. Don't use just one machine. And that's kind of where we're starting from. But there are new challenges. If you start using more than one machine, there's a bunch of new challenges. So anyone, what's one of the new challenges we might face trying to use multiple machines instead of just one? Anyone? Spread the tax. Yeah, exactly. Distributing the data to all the machines, right? And calculating overall statistics, like what happens if you want to bring back the data that you're calculating individually, bring it back and get like a total count of all the events that you've seen. So that requires communication between all of these nodes. And this also includes failures, right? So what happens when a machine goes down? The more machines that you're going to be running on, the more likely it is you're going to have a failure during that processing. And so we have this whole new set of challenges. And for a long time, people were kind of figuring this out themselves, right? They were running like xargs with SSH parameters and sending out data to multiple machines, trying to get it back, summarizing data, manually copying data around. But Google, and specifically Jeff Dean and Sanjay Gamwat, spent some time thinking about this and came up with this MapReduce paradigm. And it's a simple paradigm that allows you to do these things, allows you to do these computations over multiple machines, and tries to address some of these problems that we just mentioned. So they shared this idea in a paper, and although they didn't put out the implementation that Google had, the paper spurred a lot of ideas and eventually spawned Hadoop. And Hadoop is the software that most people use to run MapReduce programs, and it's a Java program that mrjob runs on top of usually. So today we're going to be using mrjob in kind of an emulation mode. We're not going to be requiring Hadoop. We're going to be running it just on our one machine, but it's going to emulate what would happen on multiple machines. And you're going to be using the exact same paradigm and exact same code that you would use to run on these multiple machines. So the big idea here, was to simplify the paradigm, simplify the structure that people were using to write their programs. And what that bought you was a sophisticated implementation that takes care of these details like distributing data and dealing with failures. Because you restrict what the programmer can do, you have a better idea of like what's possible and what you're able to implement. So this interface that we're going to be working with is very simple. There's going to be a map method and a reduce method. That's the MapReduce paradigm. And those are the only, for our purposes, you can get more sophisticated with MapReduce, but for our purposes, those are the two interfaces that we're going to be using today. And this implementation can be run reliably over thousands of machines or a single machine. So works the same way, easily scalable over lots of machines. So if we understand these building blocks, we can run it over large amounts of data or the sample data that we have. So what are map and reduce? So at a very high level, the map function is going to extract the property that you're interested in from, say, a log file or a view. It's going to extract the property that you're interested in doing analytics on. And then the reduce phase is going to summarize a bunch of values related to that property. And we're going to go into a bunch of examples to kind of make this more concrete. But at a high level, think about map as extracting what you want out of the data from a particular log line, and then the reduce as bringing that data all together and summarizing it in some way. Again, we have a very restricted interface, and each of these functions is going to be stateless. And what that means is I like to call it tunnel vision. So when we're looking at an individual log line or an individual review, that's all we care about at the time. If you are used to writing analytics jobs by hand, you probably have a bunch of almost global variables, right, that are keeping track or keeping tally of what you've seen so far. That is not the paradigm for MapReduce. The paradigm for MapReduce is going to be you're only concerned about one line at a time, and the framework will merge those values back together. And again, we'll go over some examples about why this is. So to make this a little more concrete, let's talk about an example. Let's say you have a URL shortening service, just a very simple service that lets you load the front page, save a URL to shorten, or redirect those URLs, right? So those are the 3 different pages that we have on our service, and we've logged, in our logs, whenever someone comes to our website, we've logged what happens. So a person has either come to the site and been redirected, they've saved a new URL, or they've loaded that home page. Does that make sense? And let's say we want to run some analytics over this log just to get these total counts. How many redirects do we have, how many loads, and how many saves? And let's say, for example, what we want out of this batch is to say, hey, the redirect has happened 450 times, the saves have happened 40, and the loads have happened 60. So let's say we want to do this in MapReduce. So what is our first step? What's the first function we're going to be calling? Map. Yes. No trick questions, don't worry. Map. So the interface to map takes in a key and a value that we want to summarize over, and it outputs sets of keys and values. So 1 or more, well actually 0 or more keys and values. So in our particular case, while we're processing these imaginary log lines, we're going to take the key is going to be a log line number. Now, for this particular example, the log line number is not that useful. So we're mostly going to ignore this initial key. And in our exercises, we're probably going to be ignoring that key mostly too. What we really care about here is the value, the log line of text, right? And remember, in the map phase, we're going to extract what we want out of this log line. And what we want is the action that took place, right? Load, save, or redirect. So we're going to extract that action and put it in the output key. And the output value, again, we have tunnel vision, so the output value is going to be the number of times that action occurred on this particular line, this particular log line, right? So what is that number? How many times did that action take place on this particular line? Once. Yes, exactly. So if we run through our log file and the mapper runs successfully, what we're going to get is a bunch of keys and values here, right? So our key is the action that took place, like load, and the value is the number of times that took place, once. So we've gone through our log, and we have a bunch of keys and values that have been output. Right? So now we go on to the next step, which is reduce. Yes. So reduce has a slightly different signature. It takes in one of these keys, and it takes in a set or a series of values. In mrjob, they're a generator, basically. So it takes in all of the values that we produced for that key in the map phase. And again, it outputs 0 more keys and value pairs. So what are the, in terms of our example, for our input, what is the key that we're looking at? An action, exactly. And what are the values? Accounts, right. So it's a, you can think of it a list or a generator of what's in it. All the ones, exactly, all the ones. So in our reduce phase, again, we have that action as the key and the counts. And what we want to produce at the end of this run is the total counts of all of these actions that we've seen, right? So in order to get the total counts from this type of structure, what should we do? Yeah, we can either do length or sum. Like, more mathematically speaking, sum is probably the safer option here, but length also works. Exactly. And so when we output the action and the total counts, then we have these key value pairs that mrjob is going to output, like redirect, save, and load. Does that make sense? Cool. So what's the point? You guys might be thinking like, damn, that was a lot of work to do a simple counter, right? But that's kind of the trade-off that we're making here. We're working in this constricted environment in order so we could do this counting over lots of machines reliably, even in the case of failure. And the stateless constraint means that one machine might completely fail, but our framework for us will manage that failure and put the data that it was supposed to process on another machine so it can process it and get it back to our reducers correctly. So that's why we have a much more complex counting procedure than, say, just putting it into a counter object or a dictionary. Let's talk a little bit about implementation, but I want to be clear, for our purposes, we're just going to be mostly writing these map and reduce steps. So we don't have to worry about how this is implemented, but when you're actually using Hadoop, you might want to know about how this works, and when mrjob emulates it, it'll output some debugging output, and you can kind of understand what it's doing behind the scenes. So implementation-wise, remember we had this series of values after the map step for all these actions and counts that we've seen. So behind the scenes, what Hadoop or mrjob will do is have a shuffle phase where it will sort all of these keys and values so that it can group all of these keys together and then easily kind of read off the values associated with each key. The shuffle phase in Hadoop will shuffle these values between, including between different machines. The shuffle phase in the emulation for mrjob, you'll see a sort output where it's literally running sort on the intermediate file so it can produce these keys and values. So again, as an overview, for these inputs, we're going to be, in theory, kind of distributing this input file over potentially multiple machines. And in mrjob, it can be multiple processes. These inputs can be split at arbitrary points for text files, split at arbitrary points so that we can distribute chunks of this file to different machines. And so it's important to keep in mind you can't rely on a linearity of your input file when processing it, right? You can't rely that you'll always process line 1 before line 2, because if we have a file that is split out and another computer is processing line 2, it's going to be processing that completely without context of line 1. And that's another reason why we have the stateless constraint. So for example, a lot of people ask how they can process XML files, where the XML files are not, an XML record is not all on one line, it's kind of spread out through the file. And while this might be possible in some ways, it's not a good fit for MapReduce because you would start at an arbitrary point in this XML file without all the context of the previous parts of it. So a consequence of this, if you're considering how to actually do logging in your application, a consequence of this is that you want all of the information you want to associate on one line. So let's look at this incorrect example of logging. Let me zoom out a hair. So let's say we're writing this URL shortener, and at the beginning of our handler, we output, hey, I'm handling this request for a particular cookie. I do some more processing, and then later in the same request, I'm saying, okay, finally I'm redirecting to a new URL. So do we have the ability to associate this in MapReduce? Do we have the ability to associate this redirect happened with this particular cookie? No. Why not? Why do you say why not? Exactly. Exactly. So the correct logging style and what we've kind of developed as a library at Yelp, and there are many other example libraries out this, is to try to log on one line all of the information that you need about the request. So if you want to store information throughout the request, you kind of have a global, or depending on how you want to implement it, dictionary of all the information you want. And then at the end of your request, you're going to dump out all of that information in one line so you could process it all together. Make sense? All right, so another example, so we can get into an example implementation, is word count. You'll see word count as a very common example for other implementations, so I just wanted to make sure you guys understood how we do it in mrjob. So in this case, we have, instead of actions, we have a block of text, and we want to look at the word frequencies, as we did in the test example. We want to look at the word frequencies across all the text. So for each line, what we're going to do is extract the values that we want to get out of it. In this case, it's words, right? Before, we were outputting only one action per line, but as this shows, you can output multiple things per line if you wish. So we're going to extract the words that we've seen on a line and the number of times we've seen that word, and then when we reduce, we do the same thing. For each of those words, we summarize those counts. So this is what that implementation looks like. We first subclass the mrjob class, and we have two methods, a mapper and reducer. We have the key and the line. So for our word count line, we're going to split this line. This is a simple way to split on white space. And then for each of those words, we're going to yield that word. So yield here is the way that we can return keys and key value pairs, right? So we've seen that word and one time. In the reducer, then, we get that key that we output and all of the occurrence, that generator of ones. And then we can just sum all of the occurrence, and then again, to output the key and value we're interested in, we use yield. And then down at the bottom, we have the kind of typical double under main function. So the mapper takes these keys and values, the reducer takes the key and generator of values and produces keys and values. For those of you who may not have used yield very much, yield is kind of very similar to return, except you can call it multiple times. It produces a generator of values. All right. So for our first exercise, we're going to be using some data that I've already loaded into the repository from the Microsoft.com website. It contains web browsing information in a CSV format, and we're going to use the mrjob framework in order to find some answers to these questions. The file tells us information. We'll use a slightly different nomenclature for this file. The file calls a particular web page a vroot. A vroot is just a fancy name for a web page that has an ID, a numeric ID associated with it. Let me load up the... This is what the file looks like. It's this MS-anon in the repository MS-anon anonymized msweb data.gz, and you should be able to see it by using the zless command. So inside this file, we have a few different record types. The ones we're going to be concerned about are A, which stands for attribute. So this associates a vroot, which is this second column here with a title and a URL, or a path, actually. So all of these A's associate a vroot ID with the titles and paths. And then we also have C's and V's. So C's are customer ID, in this case 10,004, and then all of the V nodes that customer visited. So these V's are examples of visited. So kind of similar to our URL shortener example, we have, instead of having different actions, all of our actions are visits here, right? So customer 10,003 visited these 3 nodes. For our first example, we're just going to be concerned about these visits, because we're going to want to, again, calculate the total number of visits that we've seen for these different vRoots. So the output that we want, again, is the vRoot ID with the number of visits we've seen. So we're going to group by these vRoots and summarize over all the visits. So what that will look like when you run this, so we're going to, in the shell, we're going to run Python with this top pages Python file after you guys fill it in, and you will supply the file that you're interested in reading, the anonymous MS Web data. It will output some of this debugging information, and then finally at the end it'll say vroot 10,000 was visited 912 times. And we're going to be looking to output all of the vRoots that had more than 400 visits. We'll start off with a template, which I'll load here in a second, and then run it. So let's take a break while we run this, and I'm going to load up oops. Load up the example. So again, we have the subclass happening here. This CSV read line is just a utility function for you guys to be able to read one line of a CSV file. So in our cell here, we've extracted this line, so we have these few different rows, and we're going to fill in some information if we find that the first column in the cell is V. So you guys will be filling in what key values we want to yield here, and then we can run it as I showed in the example. So any questions on this? We're going to take like 5 or 10 minutes for you guys to try this on your own, and then we'll go over the solution. So feel free to ask your neighbors or me for help. Any questions before we get started? All right, have at it. Furious typing. Yes.
So I'm very mainly familiar with Hadoop, and the Python implementation or stream,
Mm-hmm.
it outputs key value, and so on. So what mrjob does is that groups and put it in a list way.
Right, yeah.
Okay.
So mrjob will take the output from Hadoop streaming and be able to like process it, and so it does all of the kind of importing and reading from standard in. So all you have to do is write the MapReduce part.
Yeah. Like the format is kind of different. I don't have to loop over all the keys.
Right. Yeah. Exactly.
Just the key will have already.
Exactly. Yeah. So the framework is taking care of all the reading and stuff. All you have to do about is have that tunnel vision on the one line you want to process.
And second question, the shuffle and sort actually is done. Where is it done?
The shuffle. So in the emulation mode, the local mode, which we're using, it's done. It's done by the framework, and it's done using the little sort command.
Okay.
The sort.
On the cluster,
Right. On the cluster, it's done in Hadoop. So it does the sort and then distributes out the data.
On the main node, or is it?
It's on each individual node. Yeah. So it will take the original data, spread it out.
The map patterns.
Right, all the mappers.
And then the sorting.
Right, do the sorting so that they're all clustered together, and then send those groups to all together so that they can be processed. The same node will be processing the same key. Yeah, yeah. Good questions. Looking good. Good to go. Awesome. Any questions? It's in the MS Anon subdirectory. Yes. Perfect. No, you can. You do not need to uncompress the gzip. mrjob and Hadoop actually will be able to process it raw.
Like the run function calls map and then you do.
Yeah, exactly. So
how do you know that it's the first argument that's the file and it's just a convention that
yes.
the first argument is a gzip file?
The first argument is a text or gzip file. Yeah, and it'll read line by line.
And then read line by line.
Exactly. Yeah, and in Hadoop, you might, if you had a cluster, it might distribute that file to different nodes. So the framework is hopefully taking care of like how you loop over the file.
Okay. So the line is really like something that you cannot change.
Yeah,
you
exactly.
Go for 2 lines. Like
exactly. Exactly.
Even in Hadoop, like to have
yeah, there's
2 lines, like
you.
How hard coded this is.
It's I think if you're using raw Hadoop, not mrjob, we'll talk a little bit about this toward the end. If you're using raw Hadoop, you might be able to process 2 at a time. But for streaming, for processing text, yeah, the convention is it's basically hard-coded 1 line.
Like, can you add, like,
yes.
a folder as argument?
Uh,
will loop on all files
for emulation mode, I don't know about adding a folder. For Hadoop, you can add a folder.
and
yeah.
then it's the same, it will, like, concatenate.
It will. That's the thing. It may not concat. Yeah, exactly. It may distribute the files. And yeah, exactly. And if you have a cluster or the data in S3 on Amazon, it might split those up differently too. Yeah. So each mapper might download a different section of each file.
Okay.
Yeah.
Thanks.
You know, I worked at Fox.
Yeah.
And we use Hive on top
Okay.
of
Hadoop. Yeah.
And we like own like the group. I mean, we own everything. We own our analytics. We own our QA, everything.
Great.
So what interested me in this class was it's always such a struggle for us to get the analytics we want out of the data that we're getting. And running it on Hive and kind of automating that and putting it in dashboards. So you know, like they're behind firewalls and you have to go through backend to get, to run these jobs.
Right.
That's the thing I'm hoping to get out of this is can we like stay in Python, run like on top of our Hadoop cluster instead of going through Hive at all?
Yes. Yeah. So if you have an existing Hadoop cluster, we'll talk a little bit about this toward the end, but Python has functionality to basically upload itself to the Hadoop cluster and run all in Python. Yeah.
Yeah, that's what I'm very cool to.
Okay. I'll try to talk a little bit more about the Hadoop, the existing Hadoop specific stuff instead of the EMR, but it's after we instantiate the EMR cluster, it's very similar. Cool. All right. So we're going to take a look at the solution and then move forward. So let's see. So if you guys would like to save your solution, you can use Git to commit your solution. And then there is a solution in the branch EX1. So if you guys want to check that out, you can. And then switch back to master for the next exercise. So I'll bring it up here too. So the idea here is that we wanted to yield the key value pair for the vroot that we saw and the number of times that we saw it on that line, right, which was once. And then in the reducer, we take that vroot ID and yield the sum of all of the times we've seen it and the vroot ID itself. So let's take a look at that. So in the first, second column, first index of the cell, we had the vroot ID, and so we're yielding that vroot ID in 1. We took the sum of all those visit counts, and then if the total was greater than 400, although I think I told you guys greater or equal to, sorry about that, then we yield the vroot and the total.
So the data coming in on your MapReduce job, where you have cell.
Yes.
So the first yield you're doing, you're returning 1. Is that just because you think it's always going to be 1?
Good question. So we're returning 1 there because we have this tunnel vision on the single line that we're talking about. And so we've seen that 1 time. That's why we return 1. Oh, I see, I see. Sorry. So your question is, in the data, I see. In the data, what is this extra 1 here? So the, sorry I didn't cover that. In the MS Anon, when I downloaded this data, there's actually this info file that kind of describes what all these vroots mean. And what it says is the 1 may be ignored. So it doesn't seem to mean anything. Sorry about that. Yeah. If you, for some reason, had these vroots pre-aggregated, then yeah, using that number instead would be totally reasonable and probably the right thing to do. There are, in our word count example, we were also yielding the number of times we'd seen this word in 1. Theoretically, what we could do here is kind of pre-aggregate the words that we've seen on a line and yield that word and how many times we'd seen it on that line. So you can yield different numbers other than 1, but it matters like how many times on that line, on that single line, did you do it? Yeah, good question. Other questions? Great. So with these user visits, remember we had a different action, the C type, for this customer and then all of the vroots that they visited, right? So one question is, can we calculate the number of visits that each user made with mrjob? Anyone want to guess? 50-50 shot here. Good question. So the answer is no, exactly. And it's because this information is on a different line like we talked about, right? We don't know what customer ID we saw before the current line we're looking at. And so maybe if we split the file differently or rejigger the file somehow, yeah, we could. So that's the thing. So we can't assume linear processing here. But if we wanted to transform this data somehow, right? Like not all data is kind of prepackaged, ready to go for MapReduce. So there are times when you might want to transform your file so that it's more amenable to being processed in MapReduce. And in this case, you'd want either a single-threaded program, or if you're very clever about how you split the file on customers, you can maybe do this somewhat in parallel. But the idea is you need to have one or a series of single-threaded programs that are looking at this file in order, and then you might be able to, say, combine these lines and write out which customer made each visit on each line. And then you could do the processing in mrjob somehow. So we're not going to cover what this program might look like, but just keep in mind, like, you may need to transform your data before being able to process it most easily. Good.
So is it possible to, like he was saying, split the file differently? Like, I know that you make the assumption, or Mr. Job makes the assumption that each record
Right.
change that so that each record is a variable number?
In Hadoop, raw Hadoop, you might be able to do it, but it would involve kind of changing how Hadoop read an input file. We'll be talking about input formats a little bit later. That'll be outside the scope of this talk, but yeah, it's possible if you kind of change some of the underlying implementation. It is not going to be possible with mrjob because the kind of core implementation is very line-based. So it's just looking at one line at a time. Good questions. So now we want to look, instead of just getting these vroot IDs, we want to get the titles for these pages, right? So the vroot IDs, unless you memorize a lot, are not very helpful. So we'd actually like to get the 10 most browsed nodes with their titles. So nodes, or sorry, vroots, with their titles. And as you remember, we have these attributes for the vroot and the title on a different line than we have the vroot IDs and the visits. So what we're going to need to do is to join those two lines together somehow so that we can associate a vroot ID with both the number of times it was visited and its title. So sometimes we need to kind of do this self-join like we're doing now. Sometimes you guys might need to join two different files and put them together so that you can process that information together. So far we've been yielding strings and integers, but mrjob can output basically serializable objects. And that includes things like dictionaries or tuples or lists. And so what we can do here as kind of a hint is instead of just outputting the raw value, we can output a tagged value. So we can say what type of value we're looking at. Is this an attribute value or is this a visit value? And then when we're reducing all of these values together, we can behave differently depending on how that value is tagged. So what we want to be doing here is still going over and combining by vroots, but sometimes we want to be extracting the title of that vroot. Sometimes we want to be extracting how many times that vroot had been visited on a line. So that's the first thing we're going to be doing in this next example. The other thing we're going to be doing is running this job programmatically. So far we've been running this on the command line, but there might be a number of reasons why you want to actually run this mrjob as part of a larger process. And to be able to, instead of in a shell script or something like that, run this, is have Python run this mrjob either on a Hadoop cluster or like we're doing locally. There are a few reasons why you might want to do this. Testing is number one. So you might want to test that this mrjob works correctly and is outputting the right keys and values at the end of the day. What we do often at Yelp is do some major data crunching to reduce down the data, stream out those results, and then put those results in a database so that they can be accessed online by customers. So you can imagine us looking at a log, breaking down the number of times a business has been visited and showing a business owner, this is how many times people have visited your page. But we need that information, again, in an online database in order to do that. Or in general, if you want to do further processing on the result, which is what we're going to be doing, we instead of getting all these keys and values, we want to further process it, narrow it down to just the top 10. So the way you run this programmatically is in a separate file. You import the mrjob subclass that you created. In a context manager, you create a runner. You run that file, and then which will either put this on a Hadoop cluster, an EMR, or run locally, and then stream the output of that result. And this output stream, again, is kind of a generator of all of these key value outputs that you get, and you can do different things for them. This code will be in the top titles Python file, and we'll run it as part of this exercise. All right, so this exercise will be part 2, and let's take a look at the code. So we're going to count the titles. And again, instead of just looking at the cell if it's V, we also care about the text title here. So if the cell is A, then we, oh, sorry, thank you. This is the encode count underscore titles. Sorry. So if the cell is V, we're going to output some. And if the cell is A, we're going to output the title. Now, if we output the vroot here and they get aggregated in this reducer, then we're going to need to know what type of value that we're looking at is. So that's what where the tagging kind of comes into play. And then we could run this separately, and we can also run it programmatically. And so in the file code/top titles, we see an example here of instantiating this subclass, and we're going to be running this in local mode. We'll talk about other types of runners toward the end of the talk. We're going to run it, and then we're going to stream the output here. And when we get all the counts, we will sort them. Actually, this was a change I made relatively recently. So if you guys do not have this reverse equals true in your repository, you might want to do a pull, a get pull, or you could just add it in. And then print the top 10 results. Actually, I think there was also a bug correction in this, in the count titles. In an earlier version, I left out the ending colon on this line, so you might want to check that too, or do a get pull and master. So you can run this file manually, and you can also run the top titles. For top titles here, as part of the programmatic running, we've included what file we want this to run over. So the top titles Python file will not require any arguments. You could just run it as Python code top titles. So let's take a break while we fill in count titles and try to output the title and associated number of counts that we've seen that title for. And let me know if you have any questions. And feel free to talk with your neighbor. Hello. That's okay. Go to, I'll try to spin this back to the beginning. Go to the slides and make sure you've checked out the repository and installed the virtual environment. Great, great. Oh, okay. So I'd say the best way to catch up is to hit through the files and, or sorry, the slides, and just kind of read it over, and then during these breaks you can ask me if you have any questions. So I'll just pull that up and you guys can load it. I'm just going to pull up the first slide for the gentleman in the back. Whoop. So these slides have been tested in Chrome, but hopefully they'll work in other browsers. browsers too. Any questions? Yeah.
How is the shuffle not expensive enough?
How is it?
Like, because suppose you're sorting by so many keys.
Yeah.
So you're essentially sorting every line in the worst case.
Yeah, and but you're doing in the best case you have a cluster, and you're doing that sorting over the entire each node in that cluster is doing its own sorting,
Yeah,
and then
you
moving
merge
those
it.
keys. Yeah, and then move. You don't need to merge it. Each group of the same key will be sent to another node. Yeah, so that one node is processing. One key is being processed by one node. Does that make sense? So it is somewhat expensive to do that sorting, but it's somewhat necessary to group them all together. Yeah. Yeah. Sure.
Getting all the individual letters.
Yes.
That
So.
means that this is
Can you go to the reduce?
and I would like to make a print here.
Yeah. You don't want to do a print here because it will output it into the. So.
Yeah, I don't know if it's probably a list with every single letter.
So I check. Attribute is 0, 1, 2. If you look at the so 0, 1, 2, 3. Yeah, that looks right. And so. Value of what's the value 0? You might want to check your. I'm wondering if this yield is appearing to Python as inside that for loop. That doesn't make sense.
No, you should have.
Yeah. I haven't seen that error before. Because this actually looks correct.
Oh wait, no.
Oh, actually, I see what you're saying. Yeah.
I don't know why. Oh yeah, because.
But yeah, I don't know why it outputted.
I didn't see before, so it was.
Yeah, but actually, I don't know why it output all of those letters individually. Oh, it was just. I see. It was the first letter. Yeah. You're right. Good catch. You got it for me. All right. How many people would like a little more time? A few. Okay, we're just going to take a couple more minutes. I don't want to get too far behind here. Yeah. Yes. Yeah. Sorry, I had said you made. There was a update, maybe yesterday. If you do a git pull, you might be able to find it. Yeah. All right. So we're going to jump into the solution. If you don't want to know, you could plug your ears and say no. So again, we can check out X2 to look at the solution. And at a high level, there's a number of different ways to do this exercise. At a high level, what I've done is tag our values with an A or V, depending on whether it's an attribute or a visit. And I've seen some folks complete this using a dictionary, and some actually just look at whether the type is an integer or a string. So there's a few different ways to do this. Tagging it like this is kind of a general way that you should be able to use in different values. And then when iterating through the values, we extract the data from that tag tuple. So let's take a look at that. So instead of just outputting 1 for that visit, we're outputting a tuple of that this is a visit, and we've seen this once. And when we do it for title, we say this is an attribute, and we output the title. Then down in the reducer, we check the tag. So all of these, because we're using the same key here, the vroot key, all of these keys will wind up, all of these values will wind up in the same generator. And so when we iterate through this generator, we need to determine whether the current value we're looking at is a visit or an attribute. And so we kind of break those out and then yield the final title and the total. Does that make sense? Questions on this? So when you do this in the future, you can also do things like looking at the format of the file, or there are features in Hadoop and mrjob when running on a cluster to say, what file am I currently reading? And so you could kind of determine how to tag things depending on what file you're reading. Did you have a question?
How is the type preserved in the underlying thing is Java?
How is the type preserved in Java?
Because we're passing the same thing as integer.
Yeah, good question. So in between the mapper, this is the implementation. In between the mapper and reducer, we're actually using repr to serialize these outputs. And so when reading in the data again into the reducer, we're deserializing them and bringing them back as Python objects. There are other ways. You can kind of configure the way you serialize between these two, but the default is repr there. Good question. And as a follow-up, so Java does not know what the what the data is. It just looks like a stream of bytes to Java. Yeah. Any questions on this? Yeah. Okay. So the question is, how much time is spent in the Python code for mapping and reducing versus like I/O streaming and that sort of thing? It's very dependent on the job, obviously. We found that because we run in EMR and we're also pulling data from S3, we found often the bottleneck actually is that I/O. So even if we wrote these in like extremely performant Java, we wouldn't see that much of a win. There are some jobs that we have that do more like numerical calculations on the results that are probably bottlenecked on CPU, but for the most part, a lot of the time is spent in I/O. Yeah. If you have your own Hadoop cluster, that might change because the data is then stored on disk. But even in that case, just for a typical workload, even outside of Hadoop, you're usually I/O bound. So, great. And so now we can check out master again. All right. So now we're going to be looking at for the next exercise. How are we on time? Okay, great. So now for the next exercise, we're going to be looking at Yelp data. So in the Yelp subdirectory, there is, again, a gzip file called selected reviews. And these reviews, these JSON records, are going to be all on one line, remember, because we need them on one line. I've word wrapped it here for our convenience. They're going to contain things, they're going to be representative of a review on Yelp. So Yelp has a public data set. We took a snapshot of basically all the data from the Phoenix area a few months ago. And so this is one of those reviews. So it has information on the votes, so people can vote on a review to see if it's useful, funny, or cool. The user ID that wrote it, the review ID, number of stars, like 1 through 5, that person gave the business, the date they wrote the review, the text of the review, so the actual review itself. I've truncated it here. The type, so in the raw data set, a lot of these different types are can be in the same file. So a user type, a review type, business type. For our purposes, these are all going to be reviews, but that's why this type information is here. And then finally, the business ID for that review. So that's the data that we're going to be dealing with. And we're going to be talking about multi-step jobs. So far, we've been looking at one map and one reduce method, right? But not all computations you might think of can be done in just these like one map and one reduce steps. In our case, we might need to use multiple MapReduce steps, and it's kind of convenient because when we output, the reducer outputs a key and a value, key and values, and the map takes keys and values. So we conveniently have a way to compose these two functions and kind of string them together to produce multiple map and reduce steps. So that's what we're going to be doing. So for some examples of how this is used, PageRank uses this in order to kind of continually compute a PageRank value. So it'll take the output of one and use it as an input to another MapReduce job until it converges. Multi-level summaries are also useful. So if you need to group on one particular key and then take those values and group them together in a different way, you can also do that with this multiple MapReduce steps. So what we're going to be doing is looking for unique reviews. And for our purposes, we're going to define that as the number of unique words in a review. So for our purposes, again, the unique words means words that have not been used in any other review. Does that make sense? So if a word is in one particular review, it's never been used in another review, that's a unique word. Even if that word maybe had been used twice in one review, as long as it hadn't been in any other reviews, it's a good, unique word for us. So our map input is going to be, again, the line number and then the review dictionary that we just looked at. The map output is going to be that word and the review ID that we've seen so far. And that way, we can reduce on a particular word and see all of the review IDs that word has appeared in, right? And then for our reducer output, we're going to say that this review ID then has one unique word in it so far that we're looking at, if that word is unique according to our definition. If it's not unique, then we don't need to output anything. So that's our first map and reduce step. Now we need to know how many of these unique words are appearing in the review. So our map input is going to be this review ID and 1, right, from our last reduce output step. The map output is actually going to be basically a no-op. We don't need to extract anything here because we already have the data we need. And I'll show you in our code for these no-op type maps, we can actually skip specifying the mapper completely and just focus on the reducer. So finally, our reducer then is going to get our good old list of ones and the review ID and output those sums. Let's take a quick look at that code, which you will be filling in. Oops. At the top of this code, you'll see we've specified an input protocol of JSON value protocol. So let's talk about that real quick. This input protocol allows us to automatically parse this line. So in the examples we were doing before, we were putting in CSV input, and we were manually parsing that using that helper function that was in there. What mrjob can do is you can specify how these lines should be interpreted so that when you get your value in your first mapper, it's not just raw text. Instead, it's something that's been interpreted already and is now a Python object. And so mrjob provides some of these protocols, JSON value being one, that allow you to interpret these lines, and also it allows you to kind of recover from parsing errors. So again, in our previous example, if there was some problem with the CSV format and we had an error parsing it, our complete job might fail. Hadoop has some ability to specify how many failures you expect, but in general, if you're failing parsing something, you might want to completely stop the job. But mrjob provides a little more flexibility around this and can provide you saying, hey, I had trouble parsing X number of lines, so your entire job is not going to fail if we have a mistyped out JSON line. So in order to specify this input protocol, we specify the class that's desired to do these line parsings. And these classes can be pretty simple. We actually have written one that parses MySQL insert statements so that we can take MySQL dump it out, and then use mrjob to kind of process those through instead of having another file that transforms MySQL into JSON or something similar. So a protocol looks pretty simple. We have basically read and write methods that take in that raw line and then just do the interpolation into a JSON object. Again, we're not going to be filling in this code, but we will be using this JSON value protocol. And the reason why it's called value here is because we're not going to be returning any key for this. And we're going to be in our input file, we just have one line of JSON. There's no keys there. So some of you may be familiar with input formats with Hadoop. These are slightly different from the protocols that we're using in mrjob. So mrjob, again, operates on lines and tab-separated keys and values. Input format is a Hadoop Java class that allows you to specify how to interpret data on disk and translate it into the text that we need for this, for mrjob. So input formats can do things like, instead of writing raw integers on disk, you could write it in bytes. If you guys have heard of sequence files or the Parquet, I think it's pronounced, or Parquet, columnar format for Hadoop, that's what input files do. In Java, they'll read data off disk and translate it into text. For our protocols in mrjob, those are just reading the text and translating that into a Python object. Does that make sense? Any questions on this? We can talk more about how input formats play with mrjob. We use some custom input formats to, for example, using a manifest file instead of specifying inputs directly. We can talk a little bit more about that at the end if we have time. So let's take a break and complete exercise. Actually, we're going to take a double break. It's 10:15, right? And that's when lunch is? Or snack is? Can anyone confirm that? No one. Okay. We'll take a break. I'll double check. So let's fill in this unique review. We've talked about the steps that we're going to be doing, so it's going to be a matter of filling in this code. What we want is an output of the review ID to the number of unique words it used. And we're going to be running with data that's in this repository already in the Yelp folder. So we can take a look at that code real quick. Oh, there was one more thing that I wanted to show you. So now in this class, we no longer have functions named mapper and reducer anymore, right? Because we have more than one mapper and reducer. So to specify how the order in which we'd want these to run, we have a method called steps here. And this steps just returns a list of MapReduce jobs that we'd like to run, specified as using this mr function, which you pass. This is the mapper I'd like to run. This extract words. This is the reducer I'd like to run. And then the next item in the list here is, like I said, we can omit that identity mapper that we talked about and just talk about the reducer that we want to run again. So for this file, you'll be filling in those keys and values that we talked about in the slides. And some of you, again, I inserted this for your convenience. If you guys don't have this comment, you can go take a look at the file directly or do a git pull. But this is just to give you a reminder of what fields are in this record, in this record that we're passing in. And remember, this record has already been parsed for us, so it's basically a Python dictionary now. That makes sense? Great. So let's fill that in, see if we can get that running, and I'm going to double check on our break. Yeah, so the morning break is at 10:15. So if you guys would like, and what I would recommend is going outside, taking a stretch break, maybe thinking through the problem or questions you want to ask, and then it is a 20-minute break. So we'll be back here at 10:35, and then we'll continue the time to work on this question. Sound good? Cool. I'm going to grab a quick snack too. Should I just leave this on, or should I just leave this on, or do you want it back? Okay. Just keep it on.
Try sending me, put my number in your thing. Yeah. Just try sending me text.
Have y'all ever been to Montreal before? We're practically right outside the building in Chinatown. And the groceries in Chinatown are very worth going to for fruit that you won't find anywhere else. Where's Yelp? California? Weird little snack.
Downtown San Francisco?
And there's a bunch of restaurants there as well.
Yeah, first time in Montreal, so it's nice.
Yeah, mine too. First time in Canada.
Otherwise, if you're
Oh,
just kind of
nice.
exploring, go to
Where are you from?
Atlanta.
Oh,
the Orange Line station.
Yeah, it's a 2-hour flight.
So,
really?
right, the Orange Line. And on the Orange Line,
Interesting.
I know.
Yeah, I guess when I was initially planning the trip, I didn't realize how far east it was. I mean, we're basically inline Manhattan, right? Yeah.
North of New York.
Yeah.
So
Yeah.
when I go to the West Coast, it's an all-day deal.
Yeah.
Not bad, yeah. Idaho. It's hard to get from Idaho to here.
Oh. Too bad.
That's giving you a hard time picking on Phoenix.
Well, we like Phoenix, so we actually took a lot of time trying to figure out where to take that snapshot to get somewhere that kind of had a border around it, right? Like if you take somewhere like San Francisco, you might accidentally pull in a lot of people from surrounding areas, but Phoenix works really well.
Phoenix metro area is so big.
You know, but there's nothing else like beyond that metro. Well, not nothing else, but you know.
No, there's nothing.
No, we like Phoenix. we have a sales office in Scottsdale, actually.
I'm about 45 minutes from it. So.
Really good friends.
Oh, okay. Phoenix or Scottsdale?
Phoenix
Okay.
and Scottsdale.
Oh,
'Cause if
how
you-
close are they actually?
Well, they're
Not that close.
like 10 minutes.
Oh, okay, okay,
Scottsdale's like 10 minutes north of Phoenix.
okay.
The metro area is kind of weird because there's these 3 loops. There's the 101, the 202, and the 303. You can just catch any one of these loops and get you to these like areas. So.
That's cool.
But yeah, they're all right on top of each other. Anyway.
It's not strong, but I would have guessed like Minnesota or Wisconsin.
You can order yourself, so like from Maryland. If I go home to Maryland, what happens? Yeah, at the end, like, you know, after
I know, you're positive. I think,
Sunny finally, huh?
How about you?
Yeah, it's quite climate change.
No. Still cold.
Are you from like California then, or?
Yeah. Yeah, so I mostly grew up in California, and that's where I'm working now, so. California Bay Area, like, we never need a heavy jacket or anything. So I'm always like, wow, like, never wanted a scarf before, and now it's here. It's like, oh, I totally see how useful a scarf can be. Yeah, I think very close, like next block up.
Yeah. We had some good dumplings last night. Yeah, I saw a number of French places too, so I wonder. I mean, I guess it's pervasive in Montreal.
You picture a French graffiti.
French graffiti.
Oh, yeah, sure.
That's great.
For classes or whatever.
So she can identify curse words in French. Like she figured those out.
Software for experimental stations that do protein
So I ran all of our jobs, our import jobs last night.
wireless communication.
But it basically says sometimes the person actually appears in some process or whatever, right? Yeah. The signal you want there and everywhere else, just no one does. That's what we don't Here, do this. Sounds like yeah, and instead of that, like I said, during the certain data file, instead of just getting the zip loaded, inside the zip are already parts like here's a high level summary of what was going on. Here's a summary of their account understanding file, and all this kind of higher level data to help you. They don't know the difference in the result. They're both liking your Mr. Job.
Oh, good.
I didn't realize one of my colleagues was
Oh.
snuck in.
Was he sneaking behind you?
Yeah.
I got here at like maybe 8:35 or 8:40, and there was a line to register, so I came in a few minutes late.
Yeah. Howdy.
I work at Coursera, so we're sort of your neighbors.
Uh-huh. Yeah. Does Peter Alley work there?
I think he used to.
Oh, is he not there anymore? Yeah. Where are you guys located? Yelp?
Downtown San Francisco.
Okay.
You guys are
You work at Box.com.
Palo Alto?
Oh, really? It's different?
I think it's self-employed, right?
I guess.
Yeah, maybe.
I think so.
That's what I
How
figured.
How did you get the t-shirt?
In Los Altos.
Los
On
Altos?
it, right in El Camino.
Okay. What's across street?
San Antonio Road. It's
Okay.
right at the border. I mean, Palo
Yeah.
Alto, I
It's
think.
like Los
I mean,
Altos
Palo
down here,
Alto is
Palo
actually
Alto's
right
over
across
there,
the
Mountain View's over
street,
there.
and then Mountain View's like across the other
Oh,
street.
San
Yeah.
Antonio. Which side? Like near the
Oh, did go underneath?
mall area,
Oh,
or
We're just a little bit west of that, of the mall.
okay? Huh. On the northwest corner?
Well, it's not. We're on the. I don't know what the direction is. We're towards the hills, not the bay. On that side of
West side.
El Camino. Yeah, west side.
Okay. Huh.
And we're like a block side.
All right.
Yeah.
So you guys have a good setup with high-low that you'd like to stick with.
Well, it's just we wrestle as the engineers. Like we wrestle with like actually automating it. Like you know, and we have some things that are automated and we turn into dashboards, and we have great. I mean, I've been in the industry a long time, and we have by far the best analytics and metricing stuff that I've ever experienced. But there's still so much more than I wish for. And you know, like a developer writes some new code and they add some metrics or logs or whatever, and then they have to like manually go and like track it and see is it behaving the way I expect. And one, do they do that? That's great if they do, but it's like a one-time thing. It's like it'd be great if like automatically everything we had like automatically had a dashboard behind it. Now it wouldn't be one of the ones we display on our walls because we don't have so much space, but it's there if you want it. So it's all the whole thing is kind of end to end, just as opposed to we have all these one-off queries that people write, and then they just there's
no like way to put it all
So what
together.
sort of warehousing infrastructure do you use? So we have we have one eventing system that just dumps out logs into S3, and I think we use like protobuf or something.
Well, I don't know about the whole back end. The product that we work on is actually a desktop. We work on the sync product.
Okay.
So the data we mostly deal with is the log. Our metrics we get from or either if they have experienced a problem and they upload logs, we get those. So that's one set of issues. We also have metrics that we get, in real time from the product.
Okay.
And then, how is that behaving? There's some back end stuff we look at. Of course, the back end people are also interested in that. But
so we dump some of our stuff into Redshift.
What?
Redshift, which is Amazon's data warehouse.
Yeah. We started using that. We like it. It's good.
Yeah, it's
what is it called? Redshift?
Redshift.
Redshift is
It's
a data
Postgres.
warehouse as a service.
Yeah, actually,
It's Postgres.
our ops team is using it.
Yeah, are
I
they?
guess it's more data, like calling their databases as a service.
But it's still very primary. Like there are no key constraints enforced, even though it's Postgres. And so I mainly work on maintaining the Redshift cluster and getting the data we essentially want to query off into Redshift. So that's quite
Yeah, and so we actually use Mr. Job for a lot of that, like during key constraints.
Yeah, so would you have some time to chat about it? I'm sure we could.
Yeah, no, I'll be around after. I think I have a tutorial tomorrow. How's it going? Good?
So far so good, yeah.
I should go back and look at my
job last week.
What was that?
I implemented it last week, but
Oh, you did last week?
sort of in a
I did the first
draft.
Okay.
I'm actually running in sandbox mode.
working the item.
Okay.
And I was working in some editor and it was mixing tabs and space.
Wondering how else
Kept
gonna
in
work
like
if it is big. So
indentation.
I'll probably stuff to a file and run on the MR or something.
Yeah, and sometimes we've actually, I don't think we've actually done this, but we've considered using just Mr. Job, like writing a job, Mr. Job, and running it locally for a while. If we don't have that much data, running it locally, and then eventually we can scale it up if we need to. So
Yeah, that was kind of my original plan actually.
Yeah.
The data gets big, just flip to the
Right.
server.
Then you don't have to like rewrite anything, but you also don't have to use a cluster.
Write a script, run the script, you see the script is broken on line 1, you get that immediate answer every time.
Yeah, I'll probably bang on memory.
Later on, if you really try to do it,
Yeah.
you
Yep.
can't. You go to the final and you
Yeah, and some of those things don't go away, right? Like there in some reducers, if you're doing something complex, like finding a median or something like that, you can still run out of memory. So you still have to be careful about that. But at least you're not processing time.
The other cycle is, how do I learn something that I don't know how to do?
So running on a single machine, kind of banging the CPU.
Yeah. Oh yeah. Yeah. That's
Rearrange the
something
cells,
very good.
you can even add blocks of documentation. You can
Where do you
strip
work,
out
sorry?
the outputs.
I'm a contractor actually.
Oh, okay.
Save that as a file.
At where?
You email that to your
Sorry,
coworker.
in
As
LA.
long as he's got all the dependencies installed, yes, then
Yeah,
it just
it's a,
goes to the top and just goes
reward and
with the return
engagement
key. Bang, 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 bang. It
Okay.
sees everything that goes.
They basically wanted analytics on API usage.
Yep.
Logins, registrations, points earned, points spent.
Yeah.
And they had one, but it was kind of crabby, and it was kind of hard to identify where it was failing. It could have been because the API was sending it.
That if you're not using IPython,
Well, sending it over UDP, which might have gotten lost if it was too busy.
Right.
Saving the analytics as a SQLite, which
Oh.
available
having real-time metrics is great, but a lot of times you don't know what real-time metric you want, or like, do you want to start back computing old data?
Oh, okay. Okay.
All right, I'm gonna get back in case anyone needs me. Oh, okay. Great. Oh yeah, I'm supposed to tell people to rate the course too. Is it down or up? Like this? All right, so we'll spend another like five minutes or so on this, and please let me know if you would like any help, and then we'll move on to the next part.
Try to do that, doesn't work.
Oh, did you?
Yeah, it just says that.
Yeah.
You cannot
So there's a separate. So if you return that as it was, there's a. Here's the issue. So the way Mr. Job works kind of behind the scenes is it'll actually spawn off itself in order to run the map and then run the reduce step. And so if you have this in there, when it tries to run the reduce step, it'll start running this all over again. So it kind of recognizes where it is in the process. And so that's why we keep that file in a separate file and then have that run separately. I think the other thing, I haven't tried this, but the other thing you might be able to do is like, if you pass it a certain argument, then you run this code. Otherwise, you run the regular run command. You could try that too, if you want to try to keep it in one file. Yeah. So you might be able to kind of detect whether there's a flag passed, like, like run at high or like top 10 flag or something like that, and then if you detect that flag, then you run your code. Otherwise, you run the regular run method. Does that make sense?
But I still have to put this code in
Inside, yeah, and in a protected flag. Okay. Yeah, exactly. Hey. Oh, great, thank you. Yeah, question.
So, looking at this solution, here you're yielding a list rather than just previous ones yielded a tuple. Well, I'm in GitHub, so it's okay. Now I just lost where was it in code? Unique. You're yielding a list.
Yeah. So
instead of in the previous ones, we were just yielding a tuple.
Yeah, as long as it's a. As long as it's a two, yeah.
They often look the same when just the tuple's immutable.
Yeah, exactly.
Okay, so
so yeah, as long as you could get a key and a value, then you're good to go. Okay. Yeah, good question though. Right. Yeah. Sorry. It actually.
No, it looks for two values.
I think it looks for I think it
0 and 1 probably.
Yeah, I think it does. It uses destructuring to pull out the first two elements.
Yeah, so the first element is a key, and
right.
the second element is a value.
Exactly. Yeah.
That's the thing I figured out in the second exercise. It's like, where do I put that tag?
Yeah. Right. Key. Yeah, exactly. All right. So let's look at the solution. Or I should say a solution. Okay. So we're going to extract the words from the review. And so some of you may have used split. You could also use this word regular expression, which we defined up at the top of this file. And for each of these words, we're going to lowercase that word and write out that review ID that we talked about. So there's a good question in the back. This time we're using a list here instead of just a tuple. For as long as we have a key and a value, like a length of 2 data type, we are good to go on these yields. So I could, if I wanted to, I could remove these list brackets and still get the same result. Oop. So then we're going to count the reviews that we've seen for each word. So this is our next reduce step, right? And for each of the review IDs, first we're going to unique them. Like I said, in that case where a word appears in a review twice, as long as it doesn't appear in other reviews, we're fine. So we're going to unique those reviews and then make sure that length is equal to 1 so that we have a unique word. And then pop off, and this is just a convenient way to get that first element of the set. So pop off one of those review IDs and 1, because we've seen one unique word here. If we recall down in steps, we don't have a mapper for the next part. So the key and values that we output in the reducer are going to go straight to this next reducer, the count unique words for our review IDs. So for each of these review IDs, we're going to have, again, a list of ones, and we're going to sum those ones up to get our final output. Does that make sense? Were there any, did folks have any stumbling blocks? It would be great to hear about what maybe mistake a person made and had to correct so that other people can kind of hear about what to avoid. Did you have something?
Well, I missed lowering.
Oh, sure.
Just split instead of the regex.
Mm-hmm.
I got a little stuck on the count unique words because I was reading the dot string for the function saying output the number, so I was thinking, oh, do I need to do?
Oh, right. Great. Yeah, so there's actually, so one thing I didn't mention about debugging these is instead, so the way that these MapReduce, the way that mrjob communicates with Hadoop and the way it communicates with itself in emulation mode is it actually will print out these tuples. And if you are trying to debug and printing out statements, you're not going to see them in the in your output. They're going to be kind of mixed in with the regular output that you're yielding. And so Hadoop has a few ways to kind of communicate with the outside world. We're unfortunately don't have time to kind of dive into those. But mrjob has a lot of functionality for doing error logging and doing what Hadoop calls counters. So Hadoop will allow you to output counts of things that happen in your map and reduce phase, and then it'll display those on the Hadoop interface, which we'll see in a little bit. So mrjob has an increment counter function, which lets you say, hey, this type of thing happened. For example, if you wanted to increment a counter for each review you had looked at, then in the UI or in when the job ends, Hadoop and mrjob will say, hey, this happened this many times. So a lot of times for our internal metrics, we'll process a log file. At the end of it, we'll say, this is how many lines we processed, this is how long it took, that sort of thing. And we'll keep those metrics around so that we can tell, oh, you know, this day we processed way too few lines. Maybe there was a problem storing the logs. So that's the increment counter method. Again, we're not going to have time to get into it today, but it's there and available for you guys to use for debugging. All right, let's jump back to the slides. All right. So we're going to go into a little bit of kind of data science here and do a little bit more analytics work. So one of the core jobs, as I see it, at least for a data scientist, is translating an idea or an intuition into a mathematical concept or a number that can be quantified. So one example of this is we often want to suggest similar items to a user or suggest similar users that you want to follow or friend, or that sort of thing. And one of the key decisions you need to make here is what exactly does similar mean, right? How do we quantify that, right? Because if we have a lot of intuitively similar users, which one, if we only had to pick one, which one do we want to show? And I think XKCD said it best. It turns out numbers are the best way to see if something is bigger or less than something else. So as a very simple example of this kind of moving intuition into math, let's talk about just 2 points. So sometimes you could translate an entity into XY points on a Cartesian plot. So an example of this might be if you wanted to compare if two houses were similar that are on sale. So you might use the price of the house and the square feet of the house as your X and Y values, right? So with those two values, you can kind of plot them and roughly see where they lie. And so now, because they're kind of quantified, you can start talking about how similar these two houses are, right? So for you guys, and maybe you probably learned this in elementary school, what's a similarity metric between 2 points to talk about how similar they are? Or how far they are, exactly. So distance might be 1. So what's one metric we can use for distance? Anyone? Not a trick question again. How do you tell how far 2 points are from each other? What was that? Coordinates? Yeah. So there's like the Euclidean distance, right? Have you guys heard of that? Remember the x1 minus x2 squared plus y1 minus y2 squared, and take the square root of that, right? So that's the Euclidean distance. That's why you learn math. It turns out distance and similarity are 2 sides of the same coin. So if you can tell how far 2 things are apart, you can tell how near 2 things are apart, and near things are usually intuitively more similar to each other. So Euclidean distance is one metric we can use for starting to talk about analytics or similarity between 2 things. By the way, this Euclidean distance is also called the L2 norm, if you guys have heard that before. Like, people want to sound fancy, they say L2 norm, and they hope that no one else knows what they mean. But it just means this. And it's L2 because we're taking the square root and the squares here. We can actually take L3 and cube this and take the cube root. And you can actually take that up to infinity. And there's kind of different intuitive meanings for each of those. And again, that's the role of someone who's well versed in these things, to kind of know how intuitively this math should map to intuitions. So for our purposes, we're going to use something slightly different. Maybe we can't map, say, a user to these coordinate planes.Maybe we want to do something a little bit different. We're going to be using something called the Jaccard coefficient. And what that does is it tries to, again, quantify similarity between 2 sets of things. And the way it does that is it takes the magnitude of the intersection of those sets and divides it by the magnitude of the union of those 2 sets. So one place that this is used somewhat frequently is looking at strings. So we can break up these strings in a few different ways, but one of the easiest ways is just break it up into words, right? And then we treat each of these strings like a set of words, right? Jim likes pizza and Shreyas likes pizza. And so if we take the intersection of the words in those strings, how many words do we have in the intersection? 2, exactly. Likes pizza, right? And then if we take the union of those 2 sets, how many words do we have? 4, exactly. So if we have 2 over 4, we can say these are, using the Jaccard coefficient, 0.5% similar, roughly similar. Does that make sense? 1/2 is, yeah, fairly similar. The Jaccard coefficient has some trade-offs. It will, like, for example, if two pieces of text, one is very large, one is very small, even if that small one is included in the big one, they might look very different. So it can depend on your domain as to how appropriate this is. But yeah, 0.5 I'd say is getting to be fairly similar. Good question. Any other questions in this? So what we're going to be doing is comparing users, taking a look at user similarity. So one way we might be able to describe users is what businesses they've reviewed. And if we take a look at those businesses as a set and take the Jaccard coefficient, we can kind of say how similar those two users are. So what would be the value of the Jaccard coefficient if these users have never reviewed a business, never reviewed the same business together? 0, exactly. Because our intersection size is 0. They've never, by definition, they haven't reviewed the same business. So how about if they reviewed the exact same set of businesses? Correct, yeah, exclusive. 1, exactly, right? Because the sets will be the same, and so the intersection will be the same size as the union. Exactly. So we're going to have a range from 0 to 1 here, which is often something you want out of your measurements. Oops, a little typo. So for this exercise, we want to find users that have a greater than or equal to 0.5% similarity for these. And the user similarity, again, is going to be this Jaccard coefficient. So if a user has reviewed A, B, and C, and another user has reviewed F, B, and G, what is their Jaccard coefficient? Any other guesses? So, what was that? 0.2. And why do you say that? Mm-hmm. Mm-hmm. Yeah. Perfect. Does everyone hear that? So there's one business in common and 5 businesses in the union. So these two users would not meet our standard. So this code is in the user, sorry for that backslash, the user underscore similarity file. We could take a quick look at that. And this one will have a bit less of a skeleton. So more challenge. We'll have a little bit more time to tackle this one. And you guys will be able to kind of define how you want to call your mappers and reducers. Remember, after you've written them, you need to define your steps here. So you'll need to fill these in with what you end up calling your methods for each step here. We'll be running, again, with that review data, review data in the Yelp subdirectory. And those reviews, remember, they have a user ID in them of who wrote the business, who wrote the review, and a business ID of which business was reviewed. Now, the hint here is that users with greater than 0 similarity, remember, will have reviewed at least one business in common, right? So if 2 users have not reviewed the same business, we may not even need to compare them, right? Because we know that they're going to have a Jaccard of 0. Does that make sense? As a hint? All right, so why don't we dive in, and I'll try to help out with any questions you guys have. Were you guys able to get all caught up? Awesome.
sit out there and work on it together.
Oh.
Like we were working.
And you guys, yeah, again, you can talk to each other if you want. Yeah, sure.
So first, I embed business ID with the user ID.
Okay.
And then the reducer gets all the users that have reviewed the business.
Okay.
Then I emit all the pairs possible.
Okay.
And in my mapper for say user 1, I have reviewed something with user 2 like twice. I've reviewed something with user 3 5 times.
Oh, I see. So you'd then output all of the user pairs together, and then yeah, I think that should work. Yeah, it's slightly different than the sample solution, but I think that should work. Yeah.
The sample solution is probably that you're getting a set of all businesses reviewed by a particular user.
Yeah.
Rather than the reverse.
Right, but that's it would be interesting to compare the performance between those two. Yes. Yeah, although, yeah, I'd want to test it to make sure that.
When you come up with different solutions,
Yeah.
Is there a significant difference in runtime if you work with a massive amount of data?
Yeah. So.
Is there any
That's a
intuitive
good
way
question.
to decide which might be faster?
I think that, again, a lot of times the cost is in the I/O of shuffling data around. So if you can reduce the number of key pairs you're emitting, usually that can help. The trade-off is if you reduce the number of key pairs that you're doing, but you shove them all into one machine to process, that might be slower overall. And the number of parallelism that you have can play into that. So maybe you do a bit of extra work by computing something twice on 2 nodes, but your latency to computing the final will be less. Does that make sense? So I think there's a lot of factors that go into the intuitive. Luckily, I haven't found that there's like very many ways of computing the same thing. So yeah, haven't needed to like make those trade-offs before. So. Say again?
So you want the Jaccard proficient among like all the users in the set compared to
So we just want the users that are over that 0.5 or equal to or above the 0.5 similarity.
We have to compare all the users between all the other users.
Well, that's the hint, right? Like, we might not necessarily need to compute them between all of them if we know that two users have never reviewed the same business. So if there's a way that we can distribute the users so that we're not looking at user pairs that have not reviewed the same business, then we can reduce the number that we're comparing. Although, you know, inherently it's an n squared problem, order of n squared, but we might be able to reduce the actual complexity. How'd you guys go?
Pardon?
Going
So,
good?
Well, we're trying. We're both got the same. We're trying to run just the first step. We're outputting the user.
So I've seen one pair of users have a little bit of trouble outputting a set. And so one problem here is that since JSON cannot kind of inherently encode a set, you may, if you're using a set and trying to output it and yield it, change it to a list, change it back to a list, even if you use set to uniqueify that list. So you could just call the list method on that set when you're outputting it if you get unencodable output error.
Like I would have guessed that it just pickled things in the first place. You said it was using a repr to do it?
Yeah. So I believe it's using. That's a good. I should double check, but yeah, I believe it's using repr. That's just between the map and reduce steps. So usually you don't have to. Usually you're not looking at those directly, right? The output of the both map and reduce functions is going to be JSON by default. Yeah. How's it going on your implementation so far? Any questions or? Just so I can gauge time, let me know if you have a working implementation.
The user ID in this case is the actual unique user's like
It's encoded ID.
Yeah.
Yeah, yeah.
And business ID is like Bob's Pizza.
Right,
Okay,
exactly.
just encoded, yeah, okay.
Yeah, exactly.
Cool. And then the whole thing with here is I'm kind of like trying to just read it. This is how I
Sure.
learn.
Yeah.
And kind of just putting it back together. So we were just trying to correlate these two, and then also see based on just trying to see what their similarities are at the end of it, right? See
Right.
what's common about their interests, I guess.
Right. Yeah. So this is kind of it's describing a user, and the way we're currently describing a user is by the list of businesses they've reviewed. And then after we've kind of described that user, then we can compare two users.
Got it.
Yeah.
Cool. Thank you.
Mm-hmm.
So I'm yielding two and sending it
Mm-hmm.
into here, but it's saying I'm only passing one argument.
So you're yielding, right, and your reducer is log me.
I was just trying to, I would try different things right now. Should change this to a list.
No, that looks correct. I was just, sorry, I'm looking at your code. Oh, we want the reference to the function instead of calling the function. Yeah, let's give that a try. Cool. Okay. One step of the way. I hear a little bit of discussion, which is awesome. Does anyone want to say maybe where they're stuck on or what they're thinking about, and we can talk through a little bit of it? Yeah. Yeah. Right. Okay. So we're saying it's pretty easy to get these two sets where we're probably reducing on the key of user with all the businesses that they've reviewed. Right. So we've gotten this far where we have a description of a user that is all of the businesses they reviewed. Right. So now we need to start comparing users. Right. And given our hint. That we only need to compare users that have at least one business in common. How can we start grouping these users together so that we can start comparing them? Like in what way can we group users? Anyone? If they've reviewed the same business, exactly. So if we group a user by we yield all the businesses that a user has reviewed, and our key is that business, then we should, for a reducer then, given a business, we should have a description of all the users that have reviewed that business. And by description, I mean this list of businesses. So in our reducer, which has a key of business ID and a list of values, which is a list of businesses, right? And a user ID. Does that make sense? I'll take that as a no. So we kind of have this idea, this concept of a user, right? And that concept is there is a user ID and a list of businesses they've reviewed. And so we need a list of users to compare, basically. And so if we pass this concept of a user, which is user ID and list of businesses, and we group them by all of the businesses they've reviewed. So by all, I mean more accurately, any. So our mapper, given this user description, our mapper is going to output key value pairs where the key is a business and the whole user description. A business and a whole user description. Then in our reducer, we'll have this list of user descriptions, and we'll be able to compute that Jaccard similarity. Does that make sense to folks? So there'll be, yeah. So let's scroll up. How long has it been running?
This has been at least 5 minutes.
Okay, yeah. Let's look at the code.
Basically, this one is just the solution.
So it may take.
Because I bet you I could use the collections module.
Yeah. Yeah, a bit. Yeah. So. So that the trade-off we're making is sometimes can be latency for the amount of data that we can process. Yeah.
In this case.
Yeah. I agree. It's just.
With 1,000 files of this size.
Yeah. So yield for business ID.
Maybe it's because
well, one of the things. Oh, okay. Yeah. So you have that. Yeah. That all looks correct. So on mine it took, I think it took under 5 minutes, but
on this case, on Ranado's side here, it failed.
So one thing.
That's fine, but like even this one up here took a few minutes.
Yeah.
The last one.
Yeah. Yeah. So it might just be. Do you have a?
There we go. Now we got something.
Oh. And that's in MapReduce. have not. And so this is this literally the solution, or, oh, okay. That all looks correct. I'll double check running mine to make sure I didn't introduce any errors, and see how long it takes to. And which, I'm sorry.
Yeah, well, yeah, exactly. Yeah.
Which step did that end up erring on? Or how far did it get?
Typing files, sorting,
Step 1, mapper sorted.
Step 2.
Okay. Yeah. Yeah, so mine finished. Yeah, so mine finished in a couple minutes. So yeah, it might be. I have not tried running it in Windows, but
I got the
yeah.
similar out here as well.
So maybe there's a limitation in Windows sort. Invalid. Yeah. Sorry, I haven't debugged that before.
Okay. I'll just double check too. Make
Yeah.
sure everything is the same.
Yeah, and you might, what you can do if you go back to the terminal, you can actually see, you should be able to see these temp files as they come out and take a look and make sure that the data in there is as you expect. If the temp files are gone, there's actually an argument called cleanup, I believe, and you can specify cleanup is none, all caps, none, and in that case it will not clean up the temporary files that it produces. So you might go and give it. Yeah.
So when you run it locally,
yeah.
You have multiple cores. Can you spread it across each core?
Yeah. So we have an experimental implementation of that. What this does is right now it doesn't run them in parallel, but it does break up the file.
Okay.
So that at least if you're making some assumptions about it being in the same file, the implementation will break. But we don't currently run them at the same time. We decided against that because we didn't want to maintain like all the plumbing for running these and then detecting when one fails and that sort of thing. So local mode is mostly for debugging.
Mostly for debugging.
Yeah.
And just
Yeah.
smaller subsets of it.
Exactly. Exactly. All right, so we're going to take a look at the solution that we've discussed a little bit. All right, so this is the top level. Oh, let me grab those. Oh, you guys came in from outside. Perfect. So at a high level, we're going to look at each user, map the user to the list of businesses they reviewed, right? So we extract the user and business, group together those users, and then have this user description that we talked about of the list of businesses. Excuse me. Then we're going to map businesses to the list of users that have reviewed that business. And at least from what I've seen or heard from some of you guys, that was a little bit of a stumbling block because the first idea was just mapping the user ID. But a lot of you realized, oh, we can't do anything with just the user ID anymore, right? We need that description of the user, that full list of businesses that they've reviewed. So instead of just mapping that user ID, we map that full list of businesses. And now we have, in our reducer, we have all of the users that reviewed that business. And that's where this hint comes in. Inherently, as many of you guys realize, this is an n-squared problem because we're talking about all users. It's at least an order of n-squared problem because we're talking about all users compared to all other users. We can cut down the actual amount of computation we do by only comparing users that have reviewed at least one business in common. And in fact, if you wanted to get really tricky, you could start thinking about, because we have this constraint of 0.5 similarity, you can start thinking about like how many businesses would two users actually have to share in order to get to that 0.5 similarity number, right? So if a user has reviewed 10 businesses, how many businesses in common would they need to share with someone else in order to actually meet that criteria? And then you could only output that many businesses. So that's an optimization. You don't have to, if that doesn't make sense, we could talk about it after, but it's an optional thing. So in that reducer that's keyed by business, we compare all of those users and find the ones with greater than 0.5 similarity. Now, we've actually done something interesting. We've kind of made a trade-off here in order to distribute this computation, right? We're looking at all of the businesses that a user has reviewed. So in the case that two users have reviewed the exact same set of businesses or more than one business, we're actually comparing those users multiple times, right? And so our reducers are going to be outputting that user pair multiple times. So the last step here is we're going to duplicate those user pairs. But the trade-off we're making is that if we have a Hadoop cluster, those computations are happening in parallel, and the hope is that overall, although we're doing more computation, our latency will be lower because we're spreading out the work over multiple machines. And given our user base, we don't think that there's going to be that many users that have a gigantic overlap of exactly the same businesses. So that's sometimes for these types of operations that don't immediately and intuitively fit into MapReduce. That's one of the trade-offs that you sometimes need to make is doing a little bit of extra work in order to distribute the data and not share state between machines. So let's take a look at the actual code. So in that first step, we're outputting the user ID and the business ID. We're getting that user ID and the list of businesses. That I call it the user description. In this step, we're kind of defining what it means to be a user. You can imagine if we wanted to increase the sophistication of this to say, compare where the users lived, or what friends they have in common, that sort of thing. We could expand this definition bigger so that we could do more complex comparisons in the calculation. Again, so one of the limitations here when using the representations that we have between steps, we're using a list instead of a set to make sure we don't get those unencodable errors. So that's kind of just a limitation of the serialization that we're using. So in find possible, we're doing that step where we're grouping these users by the businesses. So for all of the business IDs that a user has reviewed, we yield that business ID and the pair of user ID and business IDs. If we wanted to be more explicit, we could make this a dict and say, this is the user ID to user ID, this is list of businesses to list of businesses. We could make this more complex if we wanted to. Or more descriptive, I should say. And then we calculate the Jaccard similarity and compute and yield the pair of users. And in order to make sure this pair of users is in the same order as we expect from these different reducers, we put the minimum user ID first and the maximum user ID second. I guess this would probably be better written as sorted, but this is more explicit. So we put the score that they did and then the user IDs. So now we're going to do this deduplication step in the final reducer where we're looking at the user pair. All the scores should be the same because we've looked at the full set of businesses in this Jaccard similarity. And we pop off that score that should be the same for everyone. And then down here at the bottom, we define all of the steps that we're going to be using. Does this make sense to everyone? Roughly? Yes. Good question. So user defs comes in as a generator. For all of these Jaccards, for all of these reducers, the values come in as a generator in case there's too many values to fit into memory. So we could end up with memory problems here if we have a huge set of users. We turn it into a list so that we can go back over this list in the second loop. Good question. Other questions? Cool. So a gentleman up front had another solution. Did that end up working out? No? Okay. I think there's another possible solution where you output user pairs and group by user pairs with a list of businesses that they have separately reviewed. So I haven't thought through or implemented that alternative solution. There's a question up front, and when actually comparing implementations, what's your kind of general gut feeling on performance? And a lot of times we are limited by I/O, so how much data we're passing around between the cluster when doing these different steps. So in general, you're going to try to reduce the number of key value pairs that you're outputting for each map. That's the general feeling, but it can really depend, again, on the implementation on what you need to optimize. All right, so for this last part, we're going to talk about how to deploy mrjob in EMR, which is Amazon's Elastic MapReduce service. And if there's time, I'll try to do a brief live demo. And if you guys have AWS credentials already, we can try running them yourselves in the cloud. So, so far we've been debugging effectively. We've been taking a sampled amount of data to run locally. So what do we actually do for processing real large amounts of data? So at Yelp, we use this Elastic MapReduce service. It's Hadoop. It's a Hadoop implementation that's set up by Amazon. So using an API, you're able to say how many machines you want in a cluster, what version of Hadoop you'd like, settings for Hadoop, bootstrap actions to install code, that sort of thing. And Amazon brings up that cluster, makes sure all of the nodes can communicate and are registered with each other, and then, again, makes that cluster available via an API. So for some nomenclature here, when we're talking about a job flow, that's Amazon's name for this cluster. A job flow is the set of machines running Hadoop, and you can send different jobs to them. And these jobs are one or more of these MapReduce commands. So what mrjob does for you is it nicely wraps up the different options that are available in EMR and lets you specify them either on the command line or what I think is more powerful as a set, as a config file that you can share with other people, share with your company or team. A lot of times you'll want to upload code or common set of data to the cluster so that all machines can use that while they're processing data. And there are rules or limitations about how you can do that upload. So what mrjob does for you is you could specify local files that you'd like to use. mrjob will upload those into S3 for you. Then when the cluster comes up, the cluster can pull those files from S3. Right? The cluster, by default, is not able to reach back into your local machine to pull up the files it needs. So you need to make those files available somewhere else in order for the cluster to use them. There's different options that we'll talk about for bootstrap commands and setup commands. Those bootstrap commands, you're going to get, by default, kind of a raw or limited Ubuntu image that Amazon has set up for Hadoop. So if you need extra packages or Python libraries, that sort of thing available when doing your processing, you want these bootstrap commands. We'll see an example of it, but these are typically like apt-get install commands or pip install commands. The transparent inter-job bookkeeping. So Hadoop, by default, writes out, for each MapReduce step, will write out its results. And we've talked about multi-step jobs now, where we've chained together these MapReduce jobs. But what we didn't have to specify was where to store the intermediate results. And that's what mrjob provides for you on these clusters. So it'll create a unique name in HDFS where it can store the data between MapReduce steps in HDFS so that Hadoop can easily read from them. If you're ultimately storing or getting data from S3, right, for each MapReduce step, you don't want to be transferring data back and forth to S3. You'd like to keep it local as much as possible. And so Hadoop provides that, that bookkeeping for you. It also lets you track the progress of jobs, collect errors from logs, and do job sharing. So we'll talk about job sharing in a little bit. Tracking is done by connecting to the cluster and reading the log and saying, hey, your job is 10% done, your job is 20% done, your job is 30% done, etc. So some of the settings that we'd like to use, and you can look at these settings, if you like, in mrjob-options, which contains kind of a lot of the different options you can use. This is these are some of the options which we use at Yelp. And hopefully I've remembered in all branches to X out our keys. One of the main things you need to do in order to make these API requests is actually have your AWS credentials up here. One of the next things here is the bootstrap command, which I talked about. A lot of these commands are apt-getting updating, installing different packages. Another setting here is the location for these different logs. So when Hadoop is running, it can store logs on the disk, but if the job flow shuts down when it's done and you'd like to see what went wrong or what went right, EMR will store these logs in an S3 bucket for you that you specify. These are not the actual buckets. You specify an S3 bucket that your credentials have access to write to. The Scratch UI is used to hold kind of temporary data, such as information about what job flows you have available. The SSH key, so when creating this cluster, again, Amazon will install credentials for you. You can create a SSH key using the Amazon UI or API, and then using that key connect to this cluster. And so you can specify which key that is, and the way that mrjob uses it is it uses that key to connect to the cluster and both pull logs from that cluster and set up SSH tunnels so that you can use the web interface that Hadoop provides. Normally that interface is only available on localhost, but since we're tunneling to that host, you can look at that interface from your own local machine, which is very convenient. The bootstrap behavior, I think we'll be able to get into that a little bit more. The bootstrap behavior is as I talked about, and these setup commands, the setup commands down here, which can be used to set up the code for each run that you're doing. So let's talk a little bit about that. So there's these two different concepts of bootstrap and setup. So bootstrap runs at the time your machine is created. So it's installing all of these common libraries that are not going to change between different jobs. The setup commands run at each time you run a new job. So that difference is you might set up a big cluster and have it running for multiple days as you send different jobs to it to analyze different sets of logs. And if you're a developer, each time you run a new job, you might have slightly different configurations or slightly different code. And so you might need to run a command like make if you're using, say, Python C libraries. You might need to run a command like make each time you upload your code. So that's what the setup commands are for. For bootstrap commands, they're going to be run once at VM setup. Setup commands are run each time you start a new job. Does that make sense to folks? Cool. So for bookkeeping, again, those intermediate files are stored on HDFS. When running your job, you can specify where to put the output. And I called these two out because they're a little oddly named. The output directory is where you're going to store the final output. Oftentimes for us, we store that in S3. If this is a long-running cluster, you could very well store that in HDFS if you'd like. Now by default, as we all have been doing here, we've been streaming the output so that we can look at it, right? But there are going to be many times when you actually want to store the output on S3, but not stream it out. And so that's what this no output directive, it's not saying don't store the output, it's saying don't stream the output. So maybe a little oddly named. So often in production jobs, you're just going to want to store that result somewhere in S3 so that something else can take a look at it. You'll want to use that no output option. For tracking, again, Mr. Job, if you provide a key, Mr. Job can connect via SSH and do some tracking, and then open up a tunnel so that you can look at the Hadoop output. We may have time to start this up and take a look at the Hadoop output on here, but this is kind of a standard Hadoop provided status of what your job is doing. On job, if your job fails for some reason, code's wrong, data's funky, Mr. Job will try to pull down the error logs that happened and use some heuristics for trying to pinpoint where it happened. The reason why we need heuristics is, one, it could have happened on any of the nodes, right? So we have to search through all the nodes. Maybe the error only happened on one node because of some again, funky data. And so we search through all the nodes. And then additionally, we often have extra errors from Hadoop that say, hey, my Python process crashed. And so it's easy to mistake that error, the Hadoop error, for the actual error, actual Python error. So sometimes searching through the logs is a little tricky. Mr. Job tries to make that easier. And for typical errors, it's very convenient. You can kind of track down where your problem is. Sometimes it can get tricky. A lot of times memory issues will be fairly difficult to debug because if you have Linux's out of memory killer, it might just kill off a Java process, and it's a little hard to see what happened there. But in general, it works pretty well, I think. We also do this job flow pooling or sharing of job flows, and I want to talk a little bit about why that happens. So the way that EMR pricing works is it charges you per node per hour and rounds up, right? So if you use 2 hours and 10 minutes, then it's going to charge you for this full 3 hours. And by default, what MapReduce will do is bring up a job flow instance, a job flow cluster, run your MapReduce job, and then shut it down. If you're in a small environment, that works really well, right? You're not going to be continuing to use this cluster. You want to shut it down while you're not using it. What that does, though, it ends up in kind of wasting this extra time, where you were still billed for it, but you never ended up using it. Does that make sense to folks? So what we've implemented in Mr. Job is what we call job flow pooling. And what that does is it keeps the job flow up and running. And if another job, even from another team or your own job while you're continuing to test some code, comes along, finds a job flow that's not doing anything and that's set up in the same way that you need it to be set up, it will reuse this job flow and start running it again. So our first job still takes 2 hours and 10 minutes. The job finished. It sat around for a little while. Mr. Job did not shut it down. It sat around for a little while. Someone else, completely unrelated, spun up a job. Mr. Job will look in that Scratch directory and say, hey, I notice that there's an existing job flow that's been set up in the way that I need. I'll go ahead and use that one. So it starts using that one and uses it for a little while. And then we end up not wasting as much time on average. And the final part here is that, let's say this job completes, and we're about to hit that limit of billing, right? No other jobs come around, and so what Mr. Job says is, hey, I'm not running anything. I'm about to hit my billing cycle, so I'm going to turn myself off so I don't charge you any extra money. So it's a convenient way to share jobs, job flows between jobs. As a bonus, it makes development faster because you don't have to wait for that cluster to spin up if you're doing multiple jobs right in a row.
Do you have any idea, how much money that saved Yelp?
I can share. It saved us around 15% of our EMR bill, which is pretty nice. We've done some other optimizations that we can talk about, but that was a pretty good win. Yeah. Especially, we could be much less concerned about jobs that take less than an hour. So one of the things, I think maybe one of the reasons this is too, when we talk about compatible job flows, we typically mean that the same bootstrap actions have run and that the cluster is at least as powerful as what you specified, so that there are as many are equal to the number of nodes, and those nodes are equal to or greater than in the same class. And those nodes, I think we'll talk about them a little bit. So those instance types or nodes are specified by Amazon. Those are things like M2 extra large that have a certain amount of memory available to them. Typically, Yelp uses, as you can actually see, I think in these settings, 5 instances for us at these M1 larges seem to work pretty well, although there's a lot more available now. We probably should reevaluate this to see what our optimal usage is. I think for organizations, again, I think this config file is really helpful because your developers will not have to memorize all of these options. You just say to your developers, use the standard config. If you're running out of memory, use the memory-intensive config, which uses a larger instance type, more instances, and some extra bootstrap actions to increase the amount of swap space available. And if you're bottlenecked on CPU, use a CPU-intensive instance. And using those same configs also allows you to make much more effective use of the job flow pooling. Because if everyone's using the same configurations, you're much more easily able to share jobs. For these bootstrap actions, at the end, some of them you'll see this hash sign. What this does is let you specify where these scripts live. These scripts can either be local, or as you can see here, they can be on S3. And what the hash tag specifies is make this script available to all of the nodes as a local file, and then run it. If you append a file name to the end of these after the hashtag, that's what the file will be called on the local host. So these things, instead of putting these scripts in S3, if you're trying to develop Bootstrap scripts, you could keep those Bootstrap scripts local. mrjob will automatically upload them for you and run them. All right, so how do we take advantage of all of these awesome features? We have been running in this -r local mode, or --runner local mode, and all that's really needed is changing the runner type to EMR, and then having a config file which specifies those things like the access keys needed for AWS. And instead of specifying the file locally, you could specify files in S3. Now again, if you do specify a file that's local, mrjob will upload it to S3 to make it available to your job, and then EMR will run it for you. There are some questions in back about how this works for regular Hadoop clusters. It works very similarly. So what happens for regular Hadoop clusters, we specify where that Hadoop cluster is and how to connect to it, typically SSH. And then mrjob will basically run very similar commands where it'll connect to that Hadoop cluster, run the commands, the Hadoop commands necessary, upload the script, your mrjob script itself, distribute it with Hadoop, and then run it over your Hadoop cluster. So the change there again would be, instead of this -runner EMR, we change it to -r Hadoop and specify a config file that had those configurations in it. So, excuse me, let's try finding my mouse and running this. So we're using the unique review. And I'm going to be using a mrjob conf that actually has credentials in it. Unfortunately, I can't show it to you. And then I've just uploaded this selected reviews that we've already used to one of my S3 buckets. So as you can see, it's copying some of the Bootstrap files that we needed and starting a job flow here. Job flows come with an ID from Amazon, this thing that starts with a J. Can everyone see this? Should I make it bigger? Everyone's okay? Okay. So created this new job flow. And now we're going to wait while this job flow boots up. So mrjob is going to be polling Amazon and seeing what the status of this job flow is. Now this might take a a little while it's provisioning. So we can keep an eye on it, and I'll move forward in the slides. The different stages here are going to be starting while those boxes actually come up, and then we're going to be bootstrapping. So we're going to run all those bootstrap commands, and then the actual instance will be running. So if you guys have AWS credentials or would like to get them, you can actually run, I think you can have like the tiniest of EMR instances for running for free. If it's very cheap otherwise to run them, like less than $1 for 5 nodes for one of these things. So you can go to Amazon and get these credentials, and we might have a little bit of extra time. I can help you fill in the example configuration there if you'd like to run it yourself. So that's our mrjob workflow at Yelp. We develop locally with a subset of the data that we hope is representative and has all of the types of errors we'd like to see, although very frequently we see stuff that, that is surprising. Actually, so this unique review, I ran something somewhat similar to that once, and was using a very similar regular expression to kind of find unique reviews, and ran it over the data and was getting a very weird like divide by 0 error. And I could not figure out what was going on, so I dove into the data, tried to find that review, and it was a review written entirely in ASCII art. So it did not have any words, although it did have text, so it got by my like if the length is 0 check. So it had text, but it did not have any words in it. It was all reviews. I think it was a review of a theme park, so there was like a picture of a roller coaster all in ASCII. So yeah, you never know what you're going to find with these large sets of data. So after we kind of have it running locally and I've done some tests, we run this in EMR and store the data either in a bucket or again stream it out and store it in the database available for online use. So we're still starting copying cluster information. So we can keep an eye on this. But basically, that's what I have for you guys. Again, thank you very much. I'm supposed to ask you to fill out the evaluation of this session. It's really helpful for me to get honest feedback from you guys about how it went. It's important for the organizers so they can figure out what types of things to do in the future. If you guys do not have that, do not know where to fill that out, I can look it up real quick, but it should be kind of in the PyCon website once you are registered. So I think that's it. Thank you very much for your participation. Cool. So I'll leave this running if you guys want to watch it to its startling conclusion. And if there's any questions, yeah. Good question. So how do we get Yelp data into the servers in the first place? I actually did a talk at the AWS conference, reInvent, about that whole process. But in short, we get it up there in 2 ways. One is log data, which we upload at the end of the day, basically. We use Scribe to aggregate logs up and then upload those constantly during the day. And then at like 2 a.m., we kick off all of our analytics jobs. And then for transactional data, we actually have another open source program called S3 MySQL Dump. And it's about as simple as that name is. It does MySQL dump and uploads it to S3. There's a few tricks in there about like what if your dump is larger than 5 gigabytes, how do you upload that around Amazon's restrictions? But that's basically what it does. And we have that input protocol that I talked about for parsing those statements. That is also open source at github.com/Yelp with a capital Y. That's where mrjob is hosted. And that's where some of these extra features are from. Good question. Of logs, and that was probably a year ago that I last checked at that. So A lot of that happens in parallel. You can, from different scribe aggregators, you can upload that in parallel, and you could do it throughout the day, right? You bundle it up for the hour and upload it for, you can also, your organization can also buy fiber to the Amazon data center, and so you can alleviate some of your bandwidth concerns with that with money. Yeah. Was there a question? Yeah. Good question. So it evolved as we started running these EMR jobs kind of ad hoc. And let's see. I believe we released it maybe late 2011. And it's kind of evolved from there. Some of the newer features are pretty cool. We can actually support other languages. So you can specify which executable to use. Maybe you want to use PyPy, maybe use Python 3, but maybe you want to use Ruby. And so you can actually use Ruby as an executable and tell it which Ruby script to execute as well. So you can use mrjob more for setting up your cluster and running it if you don't want to use the Python part of it.
You could write your MapReduce steps, the little code parts that we wrote, you could write it in Ruby.
Exactly, yeah, and set it up so that it uses a Ruby executor. Yeah, so those are some of the newer features. The basics have kind of stayed the same over the years. Yeah. So I think we have a list on the website, but I remember I think Pivotal had used it for a little bit. I'm forgetting. There were a few other companies I'm forgetting right now. Sorry. I think interestingly, we wrote this before a lot of the Pig Hive stuff was available. I think those are all really good options. Some of them you can embed Python into. The good and bad parts about mrjob is it brings you pretty close to the core MapReduce paradigm. So if you're trying to do something more sophisticated with MapReduce, you can kind of get closer to the raw MapReduce. If you're doing something that does translate very well into SQL, then you might be better off using Hive if you have that infrastructure already set up. So yeah, there's definitely trade-off in power there. As you could see, things like joins we had to do fairly manually, where those are just statements in SQL. Cool. Other questions? Yeah.
Are there any best practices or anything built into mrjob to like not process a file over and over again?
So by default in Hadoop, you're just going to stream the original input file in once. And so you're not really at risk of processing that same file multiple times. Are you talking about like with different jobs processing the same file, or?
You're pulling the log in from yesterday.
Right.
Is there anything to manage not processing that log again?
Oh, I see. No, nothing built into it. For EMR, it will not let you write into an S3 path that already has data into it. So you'll get a hard error that way. If you're saying like write the result into the date equivalent of the output directory and you try to do that again, you'll get an error trying to write there. But there's no state kept around by mrjob itself as to what it's processed already. Yeah. Good questions.
Any sense of the performance penalty writing
in Python? There is like a very CPU intensive, actually two now very CPU intensive jobs that we've written actually in one in C++, still using streaming, and one in Java. For these really CPU intensive ones, I think we saw a speed up of like 20% by writing it in Java. But again, most of the latency we've seen comes from the I/O, from pulling it from S3 or that sort of thing. If if you have jobs that are doing a lot of processing and have a lot of steps, you might be able to get a speed up by writing in pure Java. We found that, as with Python in general, we found that the speed of development is usually better, is usually a better trade-off than the speed of execution. Good questions. Yeah. Right. So in the back end, Mr. Job uses something called Hadoop streaming, which is the Java component which spins up an executable and sends output on standard out and reads input on standard in. And Hadoop streaming itself is line oriented. So Mr. Job by default is not going to be good at binary data. If you replaced the Hadoop streaming component with something that knew how to read and write binary output and changed the protocol, and I think you'd have to muck with more than just the protocol. I think you could do it. What we've done instead, sometimes we wanted to say process images or something like that. And what we've done instead for those is the input is actually a list of URLs. And then the mrjob does a get of those URLs, pulls down the image, does some processing, and spits out an output. For those times when we've actually had to produce binaries, we've done something equivalent where it produced the binary on disk and uploaded it to S3 itself inside of Mr. Job using the Bodo AWS library. The most extreme example of that is we had this problem loading in data to MySQL. As I said, one of the things we do with the output is load it into MySQL. We had a problem ingesting all of that data into MySQL. And so instead what we did was create the MyISOM files in EMR, upload those MyISOM, MyI, and key MII files into S3, and actually rsync them onto the MySQL server where MySQL can pick them up. So that was the most extreme, and we did that manually. So for binary data, often doing it manually is the best answer, although not the greatest answer. Good questions. Anything else? Cool. Okay. I think we have 10 minutes, so I'll definitely hang out and be around afterwards. So thanks again, guys.